Hi viewers, in continuation of part 1, so now we are going for part 2 video. See, observe here, I am clearly explaining with few examples. First example is constant, I am taking only 5. There is no pole or 0 at the origin in this problem. You have 1 plus 2s, 1 0 and 1 plus 4s is a pole and 1 plus 0.25s is a pole. So first what you have to do is put s is equals to j omega and then convert this s to j omega format and substitute wherever s is there, you convert it to j omega format. So 1 plus j 4 omega, 1 plus j 0.2 omega. So next, how to write the tabular column? Next step, first step is the problem. Second step is the convert it into s equal to j omega. So mention it as a first step. Next, second step is to make the tabular column. This tabular column is called the magnitude plot. Okay, for this magnitude plot. For this magnitude plot, prepare the table as we said in the previous video. So first term is a constant. So we are mentioning it as slope dB, 0 dB. And next, increasing order of the corner frequencies. Observe here, you are mentioning the corner frequencies in increasing order. So first he took 1 by 1 plus j4 omega. So omega C1 is what is 1 by 4. This 4, whatever omega is having constant with 4. And this 1 plus j2 omega. So omega C2 is 1 by 2. So 0.5. 1 by 1 plus j 0.25 omega. It is 4. So don't confuse whether to write a pole or 0 or anything. Don't confuse. Just you have to mention the corner frequencies in increasing order and you should mention this as 1 by whatever the omega value is having the multiplication factor that you write here. For everything the same. Okay. So next again, this 1 by 4 j omega is a pole. So you mention it as minus 20 dB. So what you have to do, this plus this. 0 plus minus 20, it becomes minus 20. And again, this plus this. What is this? 1 plus j2 omega is a 0. That's why I wrote plus 20 dB. And 1 plus j 0.25 omega is a pole. So that's why I wrote it as a minus 20 dB. So same way, minus 20 plus 20, 0. 0 plus of minus 20, 0 minus 20 it becomes. Plus of minus 20 means it becomes minus. So 0 minus 20 is minus 20. So after preparing this tabular column, clearly observe whether it is a 0 or pole. If it is a pole, you should write minus 20. If it is a 0, you should write plus 20. If it is a square, you should write it as plus 40, minus 40, like that. Okay, multiplication factor of 20. So now next step. Next, third step is to consider low frequency, one low frequency and one high frequency. Low frequency, you assume it as 0.1 radians per second and high frequency as 10 radians per second. This is our will and wish to assume this low frequency and high frequency. Some may take high frequency as 50 and some may take low higher. In some problems it is 50 and in some problems you can take it as 10 radians per second. Better take 10 radians per second. So after considering the omega L and omega H, that you should assume these two, omega L and omega H. After assuming, then you have to calculate the magnitude in GB. So magnitude in GB is given by gain. Magnitude means gain in dB is given by the formula 20 log. 20 log this multiplication factor. See here, the same step goes in each and every problem. First, at omega is equals to omega L. What is the magnitude? 20 log. First factor is 5. So if in your calculator, if you go for log 5 into 20, you are going to get plus 14 dB. Then at omega is equals to omega C1. Next, corner frequency. First lower, then corner frequency. Magnitude is given by the same term you have to write. Same term you have to write. This why we are writing the same term, you can understand after plotting a graph. That we shall see in the part 3 of the Bode plot video. Okay. So here again you should write 20 log 5. So next, at omega is equals to omega C2. See here, for omega C1 there is no change in slope. Here no slope is there. Okay. So that's why we are writing same value for omega C1. But while coming to omega C2, So there is a change in slope from omega C1 to omega C2. So see here the formula changes whenever there is a change in slope from this value to this value. Here no value is there. So that's why for this value and this value we are considering the same 20 log value. At omega is equals to omega C2. So change in slope is there. So that's why the formula changes. This is the formula gain. Gain is magnitude of j omega. A is equals to slope from omega C1 to omega C2. What is the slope from omega C1 to omega C2 is minus 20 here. Remember, slope from omega C1 to omega C2 is minus 20 into log omega C2 by omega C1. So, plus gain at omega is equals to omega C1. See this formula? Slope from omega C1 to omega C2 is minus 20 into log. What is omega C2 value? 0.5 divided by omega C1. Omega C1 0.25 plus this total is brackets plus gain at omega is equals to omega C1. What is the gain at omega is equals to omega C1? We got plus 14 dB. So plus 14, it becomes plus 8 dB. Next, again we have a change in slope from omega C2 to omega C3. So the same formula applies here. Observe here. Omega at omega is equals to omega C3. Okay, you are going to have the change in slope from omega C2 to omega C3. Same formula. If you write omega C2, so omega C1 to omega C2. Omega C3 means from omega C2 to omega C3 into log omega C3 by omega C2 plus gain at omega is equals to omega C2. So what is slope from omega C2 to omega C3? Omega C2 to omega C3 slope is 0. So 0 into log omega C3 you got 4 divided by omega C2 is 0.5 plus gain at omega C2. What is gain at omega C2? We got plus 8. Plus 8. So you are going to get this becomes 0 plus 8. And again we have high frequency we assumed. So at omega is equals to omega h. What is the gain formula? Same. Slope from omega C3 to omega h into log omega h by omega C3 plus gain at omega is equals to omega C3. So slope from omega C3 to omega h you should consider it as minus 20 into log omega h 10 by omega C3 what? 4 plus gain at omega is equals to omega C3 is 8. So this becomes 0 dB. This is the magnitude plot. How many corner frequencies you are going to get, that you should calculate. See, from here to here no change. That's why for this value and this value we are taking the same gain value 20 log 5, 20 log 5. From here to here there is a change in slope of minus 20. From here to here there is a change in slope of 0. And from omega C3 to omega h you have a change in slope of minus 20. So how to write this phase plot? 5. So 5 value we are going to write for this. The constant should not be considered while writing this 5 value. And you are going to write the 5 value as it is a numerator term. So for numerator term it is plus tan inverse. What is imaginary part? See, imaginary part is j. J is the imaginary and 1 is the real part. So for j what is the value? 2 omega. 2 omega by 1. So that's why we are writing it as tan inverse 2 omega. And in denominator actually we should write this as numerator tan inverse imaginary part by real part divided by denominator what we have? Tan inverse imaginary part 4 omega by real part plus tan inverse imaginary part 0.25 omega by real part 1. So this in logarithmic, if the denominator goes to numerator, it becomes minus. So it becomes tan inverse 2 omega minus tan inverse 4 omega minus tan inverse 0.25 omega. Sorry, 0.25 omega. I should write it here. 0.25 omega. So after mentioning here like this, So now you should take some omega values and then you should calculate the phi values. So how to take this omega values means some of the values will be the, see, low frequency we assume no 0.1, high frequency higher, I assume 10, take up to 50. That 10 value will also be their high value, and corner frequency is 0.25, 0.5 and 4. Okay, so approximately 5 values are here itself: 0.1 low frequency, 10 high frequency, and 0.5, 0.25, 4. These are all the corner frequencies. In the middle you can consider 2 values only, extra 2 values we'll consider, and then we'll calculate the phi. Substitute in the calculator in place of omega, you can replace this 0.1 and then calculate. You are going to get approximately minus 12 degrees. These are will be in degrees, phi in degrees. Okay, so if you calculate, you are going to get in the degrees. In the same process, I explained another problem also. Here this is 10 by s into 1 plus 0.4 s into 1 plus 0.s. In this s, pole at the origin. So replace s by j omega and then you write the tabular column. So 10 by j omega, 1 by 1 plus j 0.4 omega, and then 1 plus j 0.1 omega. How I wrote means this is the increasing order of the corner frequencies. So increasing order, first 2.5 small value, then 10 is the high value. 10 by j omega, omega s is a pole, so that's why I am writing minus 20 dB, and this also a pole minus 20, and this also a pole minus 20. Change in slope means minus 20 plus of minus 20, it becomes minus 40, and minus 40 plus of minus 20 means minus 40 minus 20, it becomes minus 60 dB. Same process, let us assume one low frequency, one high frequency, and at omega is equals to omega L and at omega is equals to omega C1, you are going to have the same value. See here, same I wrote 5, and here it is 10 by j omega, first value. So same I wrote here, and then from omega C2 you are going to have change in slope from omega C1 to omega C2, that is minus 40 into log omega C2 by omega C1 plus a at omega is equals to omega C1 is gain at omega is equals to omega C1 is plus 12. Okay, so like that at omega is equals to omega h you should calculate. And what is the phi value means? See here you don't have any pole or 0 at origin, but here you have a pole, no? So denominator, so phi value when you are writing you should mention it as minus 90 degrees. For pole minus 90 degrees, and denominator only poles, that's why minus tan inverse imaginary part by real part, 0.4 by 1 0.4 omega minus tan inverse 0.1 omega by 1 0.1 omega. This is the phi value. For this also you take omega values, phi values, and you take some same corner frequencies, low, high corner frequencies, and then some values, and you need to calculate the phi value. And observe this method. In another method you have a 0, 2 zeros at a origin. This problem same, you replace s with j omega. So this all are in the form of 1 plus s format, that's why we are not changing. But if it is s plus, so what we said in the part 1, then you should change, but all are given in 1 plus s format, so directly I am substituting, replacing s with j omega. Same, you go calculate the j omega square. So first is that, so it is 2, so 20 into 2 40, as it is a 0 plus 40. Same, write the pole, increasing order of the corner frequencies, 1 plus j to omega is minus 20, 1 plus j is minus 20. So change in slope 40 minus 20 and 20 minus 20 0. So assume one omega L and omega h. Okay, so you are getting doubt in this omega L and omega h, no problem, you can consider at some places omega L 0.1 radians and omega h 50, 100, 10, like that, depending on our problem. If it is high value, then you consider up to 100 radians per second. So here it is 50 omega C2. So let us consider high value as 100 radians per second. So same process, at omega is equals to omega L, omega is equals to omega C1. You are going to have for the same value 20 log j omega square, 20 log j omega square. Okay, so omega square it is given as 20 log j minus you replace magnitude. Okay, so we assumed omega L, what omega L? 0.5. So you should replace omega with omega L 0.5. Here also omega with omega L 0.5. But see, observe here the difference. Omega L here, so you should take 0.5. The formula here is same. At omega is equals to omega C1, you consider omega value what? 5. Okay, this is a small difference in these two. The formula is same. This is same. But omega value changes. And coming to omega C2, change in slope from omega C1 to omega C2 into log omega C2 by omega so on, so on. So the same process. But as here you have two zeros, it is a zeros means plus 90, but 2. So that's why it becomes 90 into 2, 180 degrees minus tan inverse 0.2 omega minus tan inverse 0.02 omega. So consider the omega values and then you calculate the phi value. And you have same another method, that is second order system given. So how to consider the omega n here means, so it will be in the form of s square plus 2 zeta omega ns plus omega n square, and compare this problem with this with this value. Okay, so omega n square is 100, omega n is 10, and 2 zeta omega n is equal 16, and zeta you are going to get 16 by 2 omega n is 0.8. So therefore g of s you replace. See, denominator now you should write in the form of 1 plus s, denominator for Bode plot. So now you should take here common 100. I am taking 100 common. In this problem I am taking 100 common. Whatever the problem is there, according that you should take common. Okay. So here I took 100 common so that it will come in the form of 1 plus s format. So 100 I took. So 100, here it is 100. So 1 plus 16 by 100 s square by 100. So 1 by 100 means 0.01 and so on. So now here you replace s with j omega. So when you are replacing with s with j omega, this 100 it is taken to numerator, so it becomes 0.75. S with j omega 0.75 into 1 plus j 0.2 omega by j omega into 1 plus this omega square. So here j omega whole square means minus j square means minus 1. So that's why I am writing here it as j omega into 1 minus 0.01 omega square plus j 0.16 omega. So now you prepare the tabular column. We can write 0.75 by j omega is, this is a pole. So write it as minus 20. And this is a 0, 1 plus j 0.2 omega. So omega C1 is 1 by 0.25. So as it is a 0 plus 20, minus 20 plus 20, 0. And again you have what is the term? 1 by 1 minus 0.01 omega square plus j 0.16 omega. So here whatever the omega n value is there, that is 10. Take that value as your corner frequency. Omega 10 should be taken as the corner frequency, and as it is a second order, you should write it as minus 40 as it is in denominator. This term is in denominator, second term. So you should write minus 40, and corner frequency is taken as omega n value is taken as the corner frequency. So change in slope 0 minus 40 is minus 40. And again how to write the phase? Phase is same. See here, constant you keep aside. So constant means 0.75 only you keep apart. Don't take that constant only, but you should take j omega pole and 0, and you should consider. Okay, 0.25 you don't consider. So write it as, it is numerator tan inverse 0.2 omega for pole minus 90 degrees minus for this term, second order term. See, this is a second order term. So whatever may be, you should write it as tan inverse j imaginary part how much? 0.16 omega divided by real part. Real part is 1 plus 1 minus 0.01 omega square. Okay. Always we write for tan inverse imaginary part by real part. This value you should consider when omega is less than omega n. And you should consider tan inverse 0.2 omega minus 90 degrees minus tan inverse 0.16 omega by 1 minus 0.01 omega square plus 180 degrees when omega is greater than omega n. So when you are taking omega values and phi values, suppose if I am taking here 1, 10, okay, 20 like this. If omega is less than omega n, what is omega n? 10 here. So if omega is less than omega n, I should consider this formula. See, come to this omega value here. It is 20. Omega is greater than, this 20 is greater than omega n 10. Then you consider this formula to calculate the phi. Then you calculate the phi using this formula. Okay. So next video, I will example with a graph and problem. Thank you.